Students, today we will discuss about Intex Questions of Amines. Now your exercise 13.4. Arrange the following in increasing order of their basic strength. Means you have some compounds like ethyl amine, like aniline, ammonia, benzyl amine and diethyl amine. And we have to arrange all these five substances in their basic strength, which is least basic and which is most basic. We will discuss about that five compounds. Now, today we have to explain this phenomena by the basicity. Okay, ammonia are not least basic, not more basic. They are having basicity between aliphatic amine and aromatic amine. Okay, now here ammonia will be in middle form. Okay, now here this is ethyl amine, this is diethyl amine. You know very well that ethyl group shows I effect. That means ethyl group, alkyl group shows plus I effect. That means they donate the electron toward the nitrogen, so the electron density on nitrogen will be increases. But here two alkyl group is there. That is why the electron density on nitrogen will be very high in comparison of ethyl amine. So we can say that diethyl amine is more basic than ethyl amine. Okay, here you can see the structure CH3CH2. You can see diethyl amine. Now these ethyl and these ethyl, both these ethyl shows plus I effect. That means the nitrogen, the lone pair electron on nitrogen will be increased. So we can say that the density of the electron on nitrogen will be increased because these alkyl group shows plus I effect. That means inductive effect, plus inductive effect, positive inductive effect. So diethyl amine will be more basic and ethyl amine will be slight lower basic. Now in this three category, aromatic amine, that means aniline, benzyl amine and ammonia. Now you can see that benzene like this. This is aniline. Due to resonance structure, you can see that here benzene ring which are having 3 pi bonds. So these nitrogen containing lone pair electron which will be delocalized on ortho form, on para form, on ortho form. That is why these electron will be delocalized, and due to delocalization of electron, the electron density on nitrogen will be decreased. So all the electrons will be going toward benzene ring. That is why electron density will be decreased on nitrogen. So protonation will be very hard. So it does not accept H+. So this nitrogen does not get protonated. That is why aniline is least basic. So we will take C3h9n which is least basic, then ammonia. Now here ring which shows minus I effect, and this carbon, that is methylene group, which shows plus I effect. That is why we can say that benzyl amine is more basic than aniline. Benzyl amine which is more basic than aniline. So we have to take C6H5NH2, CH2NH2 in this manner. Thereafter ethyl amine, thereafter diethyl amine. So this is the increasing order of basicity of compounds, aniline or amine compounds. Why we are putting anilines over here and why we are putting diethyl amine over here? Because aryl amine shows least basicity and alkyl amine shows most basicity. That is why ammonia express the basicity between aliphatic amine and aromatic amine. This is between aliphatic and aromatic. That is why ammonia is putting over here. Okay, now second we will discuss about ethyl amine, diethyl amine, triethyl amine and aniline. You know very well that here C3h9n we discussed previously. There is ring contained NH2. The electron, lone pair electron on nitrogen, which will be delocalized. That is why electron density on nitrogen will be decreases. That is why H plus proton will not accept very fast. That is why protonation will be very less in amount. So here aniline, which shows least basicity. Now you know very well that here alkyl group, ethyl, 2-ethyl and 3-ethyl. When ethyl groups are given with nitrogen, that means here two effect. One will be inductive effect and second will be steric hindrance. By calculating these two effect, plus I effect, I will write over here plus I effect and thereafter steric hindrance. Steric hindrance. Due to these two phenomena, aniline, which are putting over here very first. Now here ethyl amine, diethyl amine and triethyl amine. Due to these two effect, plus I effect as well as steric effect, steric hindrance, we have to put C2H5 twice NH. Secondary amine, diethyl amine, which is most basic in all these amines. Okay. Thereafter C2H5 thrice N and thereafter C2H5NH2. So this is the manner of basicity. Clear? Here what we have done? Aromatic amine, because aromatic amine shows least basicity. Why? Because C6H5, which is aryl group and which shows minus I effect. That means electron density on nitrogen will be decreased. That is why N, which should not have lone pair electron, which will be attracted toward the benzene ring. That is why this will be least basic. Now among these three, primary amine, secondary and tertiary, these three amine shows plus I effect as well as steric hindrance. That is why diethyl amine, which shows more basicity than triethyl amine and which is more basic than ethyl amine. So we have to write in this manner. Okay, now here methylamine, dimethylamine, trimethylamine, aniline and benzylamine. As you know very well that here aniline, which is aromatic amine, and this phenyl group which shows minus I effect, that is why aniline which shows least basicity in this group. So C6H5NH2. After that, here benzylamine is given. In this case, your phenyl group will be electron withdrawing, and thereafter methyl will be electron donating group. That is why this benzylamine shows more basicity than aniline. So we have to take at second number C2H5CH2NH2. Clear? Okay. Thereafter you are given methylamine. Now methylamine, dimethylamine as well as triethylamine. In these three cases, we have to study about plus I effect as well as steric hindrance. After studying these two effects, plus I effect as well as steric hindrance, you can very well understand that this methyl, like CH3 twice NH, which becomes more basic than CH3NH2, and which is more basic than CH3 thrice N. So this is order of basicity in amine compounds. In this question, we have to focus on two steps. First one, aliphatic amine, which is more basic than ammonia, and aromatic amine, which is less basic than ammonia. So these phenomena can be understood by this topic. Thereafter, if bulky group is present, then steric hindrance can be counted. So by this phenomena we can explain and we can put over this increasing order of the basicity of amines. Okay. Okay students, now we are moving on 13.5. Complete the following reactions and name the products. We are given two reactions and we have to complete, and thereafter we have to make a name. It should be or IUPAC or a common name. Okay. Here propyl amine is given and reacts with HCl. So what will happen? Now the nitrogen, the electron density on nitrogen which gets hydrogen, that is why we can say that the protonation reaction will be there. That is why CH3, CH2, CH2. Now NH3 and Cl minus will be remaining. This became salt. Now here propyl is in normal form. So normal propyl ammonium chloride is formed. Normal propyl ammonium chloride is formed. Thereafter second one, triethylamine is given. Now which reacts with HCl, then salt will be obtained. Here also the electron density on nitrogen, due to the electron density on nitrogen, hydrogen is going toward the nitrogen. That means protonation will be there. That is why C2H5 thrice N plus HCl and Cl will be minus. You can say. So here triethyl ammonium chloride is formed. Triethyl ammonium chloride is formed. Triethyl ammonium chloride which is formed. Now here, write reaction of final alkylation products of aniline. So we have to make alkylation of aniline with excess amount of methyl iodide in presence of sodium carbonate. So we have to do alkylation by using methyl iodide and thereafter sodium carbonate. And all these manner we have to discuss about the IUPAC of the structure. So now aniline should be taken. This is my aniline. Ring contain NH2. You know very well that electron density of nitrogen due to lone pair electron of NH2. Now aniline reacts with methyl iodide. That is why H and I will be removed. So for that, an alkyl aniline, that means an methyl aniline is formed. Thereafter second time, if excess methyl iodide is given, then what will form? This hydrogen and this iodine will be removed. So this methyl will be going toward nitrogen. That is why N dimethyl. N dimethyl aniline or benzoyl which is formed. Thereafter, by using excess methyl iodide, so what will form? Here methyl will be going toward the nitrogen. That is why here N contain thrice time, 3 times methyl. There iodide will be external part of this cation. Okay, so this is your NNN trimethyl, NNN trimethyl ammonium iodide salt. NNN trimethyl, NNN trimethyl anilinium iodide, anilinium iodide salt. Okay, here aniline was given. Here N-methyl aniline formed. N-methyl, this is aniline. Now here N dimethyl aniline is formed. N dimethyl aniline is formed, and thereafter excess methyl iodide is given. Then NNN trimethyl anilinium iodide salt is obtained, and thereafter if you are using sodium carbonate also, Na2CO3, then what will form? Then this sodium removes with iodine and forms 2 moles of NaI. That is why this carbonate which is attached with this salt, okay, this carbonate which is attached with this salt, so I will be removed and carbonate will be obtained there. So your structure will be like this. NNN trimethyl anilinium NNN trimethyl anilinium carbonate, right? But this is 2 times because carbonate is having -2 charge. That is why, which is divalent. So we have to put here 2, right? So this is the structure of this complete reaction. This is the final structure, and IUPAC name will be as under NNN trimethyl anilinium carbonate. Clear? So this is complete question. Okay. Let us move 13.7 and 13.8. Write the chemical reaction of aniline with benzoyl chloride and write the name of the product obtained. Okay. Here we are given aniline and we have to take a reaction with benzoyl chloride. Okay. Here NH2 ring contain NH2, that means this is my aniline or benzeneamine. Aniline when reacts with benzoyl chloride. Now what is your benzoyl chloride? Ring contains COCl. This is benzoyl chloride. Okay. Now here H and Cl will be removed, so HCl will be removed, and this benzoyl group will be attacked toward the nitrogen. That is why here NHCO C6H5 is obtained. Now N contain aromatic ring. So N-phenyl, this is benzamide, benzene and amide. This is amide and benzene, benzamide, N-phenyl benzamide is obtained. Now you can say in common word, in common name, this is known as benzanilide, N-phenyl benzamide, which is your IUPAC name, but common name will be benzanilide. Okay, so this was your 13.7. Now write the difference isomer of C3h9n. This is amine. It should be primary or secondary or tertiary. We have to make isomers. First one is this. Write IUPAC name of isomers of these compounds and isomers which will liberate N2 gas on treatment with HNO2. So we can say that first of all we have to find out these 4 or 5 or whatever these C3h9n isomers. 4, 5, 3, whatever, we don't know that which one which liberate N2 gas with HNO2. First of all we have to make some isomers of C3h9n. Let us discuss about isomers of C3h9n. Here carbon 3, which is in C or C pattern. So this is my CH3, CH2, CH3. This is my propane. Now here 1H will be substituted by NH2. So we can say that 3 plus 2, 5 plus 2, 7 plus 2, 9. So 9 hydrogen is there, here also there. 3 carbon, 1 nitrogen. Okay, clear. So this is my primary amine which is having name 1-propanamine or propane 1-amine. Okay. Now, we have to make isomers of this compound. So, this NH will be going toward the second carbon, that is why CH3, CH, CH3, NH2 will be going towards second carbon. So, this is my propane to amine. This is propane to amine. You think that this is my primary amine. This is also primary amine, because if any amine compounds, nitrogen is having 2 hydrogen, which will be known as primary amine. Nitrogen is having only 1 hydrogen, which will be known as secondary amine. And nitrogen doesn't contain any hydrogen, so which will be known as tertiary amine. Here 2 amines, both are my primary amines. This is my 1 degree amines. Now we are moving for second 2 degree amines. Here NH2 now which will be going toward this both 2 carbons. Now NH will be going toward this carbon, so my amine will be like this: CH3 CH2 NH CH3. Okay. Thereafter this methyl will be going toward this nitrogen, so CH3 and CH3. This is my tertiary amine. So this is secondary amine. This is tertiary amine. What is the name of this compound? N-methyl. N contained methyl. This is my ethanamine. And methyl ethanamine. Thereafter N dimethyl methanamine. This is my N dimethyl methanamine. Okay, so this was my isomers, primary amine, secondary amine and tertiary amine. Now, second question is this: which will liberate N2 gas? Among these 4 compounds, which will liberate N2 gas by the treatment with HNO2? Now, nitrous acid reacts with only and only primary amines. Nitrous acid, HNO2, does not react with secondary and tertiary amine. So, here we will put 2 equations of CH3, CH2, CH2 and NH2. Now, reaction with HNO2, this will be converted because HNO2 contains OH group as well as NO group. Now OH will be going toward this side, so propane 1-ol will be formed, CH3CH2OH plus N and N will be made N2 and thereafter H2O. So we can say that here primary amine reacts with nitrous acid and then form propane 1-ol. So this is my propane 1-ol. Thereafter, if we are moving for propane to amine, CH3, CH, CH3 and NH2 is there. Reaction with nitrous acid. So nitrous acid contains 2 parts. One will be OH and second will be NO. Now OH substitute this NH2 and forms CH3, CH, CH3 OH plus this and will make N2 and this H2 and O will be made H2O. So we can say that this is my propane to all. This was my propane 1-ol. So we can say that in this question, first one, isomers of C3h9n. In these four isomer, first two will be of primary amine, third one secondary amine, and fourth one tertiary amine. Among these four amine, only primary amine give the taste with nitrous acid and forms alcohol. Propane 1 amine gives propane 1-ol and propane 2 amine gives propane 2-ol. In both the cases, N2 gas will be liberated. Okay.